have to talk about this. It's called the intermediate value theorem. And like normal, this is very wordy and probably confusing, the definition or what exactly this theorem means. But it always makes sense after you've tried it. Well, usually makes sense after you've tried it a few times. So here's the math words because we need to learn to read math. If f of x is continuous over a closed interval, AB, we talked about that, yeah. In other words, the graph goes on and on and on. It doesn't have any breaks or gaps or holes or whatever. It goes on and on and on. And k is a value that is between f of a and f of b, then there is at least one c such that f of c equals k. So what does that mean in English? That means this. It means that we have a graph here, for example, a graph that is continuous over closed interval AB. And I have this value, and if you didn't draw this in your notes or put this in your notes, you need to have a value of k over here on the y-axis. So if you didn't, that's important. And it is also important that that value of k shows up in between the f of a and the f of b. Don't put it below, don't put it above. You have to put it right in the middle of them, or not in the middle, but in somewhere between them. And it says that there is at least one c value. So one c value meaning that that c value has to be in between the a and the b. The c has to be somewhere in here. That might be something you want to add to your notes because I didn't have that up here before. There's at least one c value such that when you found the value of the function at that c value, you would get the k. So in other words, if this is the k value, you read over to the graph, the c value might be right here. F of this c would be k. You with me? There happens to be a couple of other places that the c could be also. The c might be here, the c might be here. But it says that there is at least one c value. If we know this is continuous, there's going to be a c in between a and b so that it has some value of k that is between f of a and f of b. In fact, I might even do this. Here's f of a. This right here is f of b. This is f of a. This right here is f of b. That's what the intermediate value theorem means. Still probably doesn't mean much until I start talking about some examples. So, let's move down here. Example 1. F of x is equal to x cubed plus 2x minus 1. First of all, how would you describe this graph? X cubed plus 2x minus 1. Don't graph it, just tell me about it. It's a what? Say it again. It's a polynomial. Polynomials are continuous. They are. So this thing right here is a continuous graph. You need to know that. Polynomials are continuous graphs. You may even want to make a note of that. I wrote it right here. It is continuous. It's a polynomial. Polynomials are continuous. Is there a zero? Is there a zero in the interval from 0 to 1? So the question, first of all, is the graph continuous from 0 to 1? Well, it's a polynomial. Polynomials are continuous everywhere. So is it going to be continuous from 0 to 1?
Yes.
Yes, absolutely. So, yes, it's continuous. It's a polynomial. All right? Now what we need to do is figure out what is the value of f of a. Well, a in this case is 0. Mark that. That's a. What is this 1 then? The 1 is b. So what is f of a? That means what is f of 0? So I put a 0 in here, x to the power of 3 plus 2x minus 1. I replace the x's with 0, and I calculate the value of the polynomial. When you put a 0 in here, you end up with negative 1. So we are checking, remember we're just going from 0 to 1, so we are starting right here at an x value of 0, we're ending right here at an x value of 1. So when I replaced x with 0, I have a y value of -1, so I put a point right here. If it's not dark enough in your notes, make it dark in your notes right now. Now what I need to do is figure out what is the value of the other end of the polynomial of the interval that we're talking about. So I put a 1 in there. So I'm figuring out what is the value of that polynomial when I replace x with 1. So I have 1 cubed plus 2 times 1 minus 1, we get 2. You with me here? So I put a point up here. We know it's continuous, right? We don't know what this graph looks like unless we actually graphed it on our calculator, but we know if it's continuous, just like we talked about above with the intermediate value theorem, that this graph has to connect. You with me? It's continuous. So the only way I can get from here to here is if I connect them with a continuous curve, line, whatever. So the question, remember the question is there a 0 in the interval? Is there a 0 in the interval? How do you know there's a 0 in the interval? Because it crossed the x-axis. It crossed right over the x-axis. This point right here, that is our 0. How did I know there had to be a 0? Well, our first y value was a -1. Our second y value was a +2. The only way that I can go from a -1 over here to a +2 is if I cross over 0. So I know there has to be a 0. So yes, there will be a 0. That's what the intermediate value theorem tells us. All right, try one more. I would like you to get your calculators out for this example. I want you to type in x minus 1 divided by x squared minus 1. Make sure you separate the top from the bottom with parentheses. When you graph this, you get a graph that kind of looks like this. Yes, would you agree? Mm-hmm. Graph looks like this. We are trying to figure out whether or not we can find a C value. That just means some value on the x-axis. I'm going to label that x-axis. Some x-axis value that will get us 1/4. Is there some x value that's going to get us 1/4? So notice though we are talking about only this interval. We are only talking about the values from 2 until 4. So we have this graph is not continuous. Would you agree? Yeah. But hopefully you would agree that it is continuous from 2 until 4. Do you see that? Right in this area, the graph is continuous. Over here at -1, it is not continuous. So we're only concerned about what's happening over here. From 2, where we go? Here we go. From this 2 right here to this 4 right here. So is it continuous in this interval? Yes, it's continuous. We looked at the graph. It's continuous. Now what we need to do is figure out what is f of a. Well, a, remember, is the 2. This right here is going to be the b. F of a would be the same thing as f of 2. So we plug a 2 in for these x's. You still with me?
Yeah.
You end up with, if you do the math, you end up with 1/3. Now you check the other end of your closed interval, which is a 4. So you take that 4, you plug it in for your 2 x's, you're going to end up with 3/15. That reduces to 1/5. So we are trying to, if we were to graph this, we would get one end would have a y value of 1/3, the other end would have a y value of 1/5. The question is there an x value that would get us 1/4? Well, I hope you would know that 1/3 and 1/4 shows up in between 1/3 and 1/5. Are you okay with that?
Yes.
1/3 is 0.3 repeating. 1/5 is 0.2. we're trying to figure out, is there some x value that will get us 1/4? Well, 1/4 shows up right in the middle of it, not right smack in the middle, but somewhere in between. Would you agree? So there's going to be an x value. If this is a continuous curve, it keeps going. It has to cross over some x value that will get us a y value of 0.25. Yes? Okay. Very short assignment today. So if you are caught up on everything else, enjoy it. And did I say short assignment?
Yeah.
Okay, so it's like 6, 7, maybe 8 problems long, maybe something like that.
Maybe.
Maybe, yeah, maybe.